can see the screen.
Okay, Parmesh, did you join? No, I think. Okay, is my voice clear, Rajasingh?
Yes, sir, it's clear.
Okay.
I think Parmesh muted himself.
He's not joined the call. He's on. He just joined the meeting, but he didn't join the call.
Yeah.
Did he join yet or not? Parmesh? Hello?
Hi, sir. I can see him as an attendee. I can see in the list, but he's
Yeah.
his
Yeah,
microphone is muted.
this is not active, so that means he did not join yet.
Okay. Yeah, he texted in the group. Yeah, he'll be coming.
Yeah. Okay, so did you read this slowly changing dimensions here?
Yes, sir. I've read it.
Okay, so can you explain on what is normalization and denormalization if you already read it?
So, in the normalization, we want to efficiently organize the data in database. So we split the present tables into new tables, into additional tables for eliminating the redundant data. Already present data from, if the data is present in more than one table, we want to divide those tables into additional tables so that we can save the space, disk space.
Okay.
That's in
Hi, bro. Actually, I got a call.
Okay.
Regarding the job.
Okay. Yeah, go ahead, Mark. Denormalization.
We'll be optimizing the read performance. We try to optimize the read performance in denormalization by adding redundant data to the present tables.
Okay, good. Okay. You, Parmesh, did you read the normalization and denormalization?
Yes, I understood that. Normalization is optimizing the data to reduce the redundancy. That means reducing the duplicate values.
Okay.
Denormalization is able to create the tables to view the in a readable format. It is quietly increase the redundancy. Yeah.
Okay. So denormalization is basically it will increase the redundancy. It will also basically you are creating more tables to see the more summarized data. What happens is because you have more tables, it will take more disk space, and then it will also increase more maintenance. Okay, maintenance on the
duplicate values are present in many single data is present in many tables. That is increases the database size.
Yeah. Okay. Okay, good. At least you have to know the basic things. Otherwise, you have to be in a position. You have to be in a position to take a vendor calls because the most of the times vendors are Indian. So when an Indian guy calls, he will say, "Okay, I'm going to arrange a meeting right now. I'm going to arrange an interview right now, so he's going to ask questions, even though he doesn't know what he's asking about, but he will ask you questions. So you just have to be in a position to answer those questions. Okay. Forget about the final interview, but at least you have to be in a position to take vendor calls. So if you fail in vendor calls, you won't even get the interview. So that is very important, vendor calls, and you might get interview also from the vendor sometimes. They don't give you time, they just call you and they will ask you questions. So you have to be prepared for the basic questions, because they will not ask you any deep questions, but they will just touch basically the basics. So you just have to be ready. Okay.
Yes.
So ready guys, last concept in the data warehousing I want to cover, which is very, very important for the data warehousing and also in the ETL. In the ETL, we can go through a small example for the slowly changing dimensions when we start the ETL. At one point, I will go through, there is a very good example document. I will go through how to implement the slowly changing dimension with the ETL tool. Okay, but right now, just let's go to the theory. It is simple, but applying this in the ETL is little complex, because you have to use more stages and all. But anyway, I will cover that. Okay, let's go to slowly changing dimensions. Okay, simple. You can see here it is slowly changing dimensions. Okay. Okay, let's go to okay. Slowly changing dimensions is a concept. It's nothing but a problem is a common one, particular to a data warehousing. In a nutshell, this applies to cases where the attribute for a record varies over time. Okay, so I think I explained the concept not yesterday, but day before yesterday. I did explain something similar to this. I've given the example also with the USCIS. I don't know if you guys remember it, right?
Yes.
I've given right now you're living in Farmington Hills, but if you move to California or something, they will add you extra row in the USCIS data warehouse, right? Database. I explained that. So this is something similar. Okay. So somebody, okay, some person A, okay, with ABC INC. She first lived in Chicago, Illinois. So the original entry in the customer lookup table has the following record. Okay, so basically you have a key and then your name and then your state. You lived in Illinois. Okay, at later date she moved to Los Angeles, California on some date. And how should ABC INC now modify its customer table? Okay, so this was the original row, and now the customer is moved, her address is changed. So how the company should handle their database, okay, handle their table, right? So it depends upon what kind of a rule or what kind of a data warehousing concept you are following. Okay, you can use star schema, you can use Snowflake schema, you can use anything. And then also when implementing slowly changing dimensions, there are 3 different types. Based on your organization, you can define your rule. You can use any slowly changing dimension you want. The slowly changing dimension is just a concept, okay, nothing else. It does not exist physically, but it's just a concept, okay. So there are 3 types. Let's see. The first one is the new record replaces the original record, okay. So what happens? This row will be replaced with the new row, okay. The key will be changed, name will be same, the state will be changed, okay. Second one, the new record is added into the customer dimension table, okay. So basically this will be there like that, and then another extra row will be added with the new key, name, and the new state, okay. Type 3, the original record is modified to reflect the change. So you guys might be confused with the third one, but I will show you. It is also simple, okay. So let's go to type 1, slowly changing dimension. So type 1, see, simple. So 1001, name, Illinois, she moved to California. The key could change, or you can update on the same key. Update, so basically instead of inserting a new row, you are just updating the same row in the type 1, okay. So the key stays same, the name is same, and the state is different, okay. So let's see the advantage. This is the easiest way to handle slowly changing dimension problem, since there is no need to keep track of old information. Okay, this is easy, but what you are missing is you are missing the history. So in the future, if you want to know where the customer was before, you don't know, because you don't even have a data in your database, right? You basically updated. You don't have anything.
Yes.
So that is a disadvantage. But the advantage is, because you are not keeping any history, the maintenance is low. So you will not have lot of data sitting in your data warehouse, right? You only have very few data. You also have very latest data. So that is the difference. Okay, usage about 50% of the time. So that means most of the companies, they don't use. Only 50% of the companies they use. Okay. So when to use it? Type 1 slowly changing dimension should be used when it is not necessary of the for the data warehouse to keep track of the historical changes. Yeah, I explained. So when you don't need the customer history, location history, and all those things, when you don't need, you only need the current data. Then yeah, just go with the type 1. Okay. Next, type 2, simple. You have the old data 1001, and then new key column is added because you are inserting a new row. So the key is different, name is same, just the state is different. Okay, so that is the type 2. So this allows us accurately keep all historical information. Disadvantage, this will cause the size of the table to grow fast. Okay, in cases where the number of rows of the table is very high to start it. Okay, so you have so many customers. Just give me 1 second, okay? Hello? Okay, yeah. So the type 2 is like that. So the disadvantage is, because the data will go fast, you have a huge disk usage. Okay, so when to use it? When you want to store the customer history information, then you can use the type 2 slowly changing dimensions. Okay, so let's go to type 3. The type 3 slowly changing dimensions is basically you have one row. Okay, so everything stays the same, but you will add an extra column. Instead of extra row, you will add an extra column. See, it's an effective date. Okay, so you have the original state, you have the current state, you have effective date. So basically, the current state you have as the California. The effective date means from when the address was updated, you have that date here. Okay, that is the effective date. So advantages, this does not increase the size of the table since new information is updated. This allows us to keep some part of history. Okay, so basically you will not know how long she was lived in the other state, but you will only know when the effective date, when she moved to the new state. Okay, so disadvantages, we already read. Disadvantages, this type will not be able to keep all the history, because so what happens if she moved again, if the customer moved again, you have to add another row and another column, right? So you have to add another column here. So basically the information is not exactly visible. Okay, so you have to keep adding the columns. So that is basically the rows. If you add rows, that is different, because it looks, the visibility is good and you can see the information, you can see the dates and all. But here you have to keep adding the columns. Same thing, that will also grow the disk usage. Okay. For example, if the additional ladder moves to Texas, same thing as I said. So you have to keep adding the columns if the customer moves again. Okay. The type 3 is rarely used. So this type of slowly changing dimension is not used much. Most of the custom companies, they use either type 1 or type 2. Okay. Okay, so yeah, that's it. I think we should be good to go from the data warehousing concept.
Only three types are there.
Yeah, only 3 types are there in the slowly changing dimensions concept. Okay.
But I saw another website. It shows like
Mhm.
there is a type 4 and type 6 also is there.
Nobody uses it because they might have another types also, but in the ETL perspective, you only use type 1 and type 2. You don't even use type 3. Very rarely use type 3. Okay.
Okay.
So far I only used one type, the type 3. There, basically, we don't even have the original state column or current state column. I only basically I used to go and update the state name to California here, and then we used to have a flag this month effective date.
Okay.
So I don't even have this one. Basically, the original state we don't even use it, but we only use just the state name, California, and then this will have the effective date. Okay.
Okay.
Yeah. So that's what I used to do with the type 3. I only used one time so far. So it's very rare. The companies don't even use type 3. Most of the times it's 1 and 2. Okay. Yeah, so I think that's it. We can move to SQL. So where we are yesterday, we are done up to SQL comments, right?
Yes.
Okay. So next, the creator, creating, basically creating and dropping. Okay, this is the concept of. Do you guys know what is DML?
Data DDL, DML, and
Exactly. So inside SQL, DDL,
DML.
DML, okay, and DCL is also data control language, okay. So DDL is data definition language, data manipulation language, data control language, okay. So DML, the insert into update, basically whenever you are modifying the data, then it's a DML, data manipulation, okay. That's a DML. But what is DDL? Data definition. Whenever you are touching the definition, like when you are changing the column names, when you are dropping the table, when you are renaming the table names, when you are renaming the database name. So whenever you are touching the database structure, then it's a DDL, data definition language. Okay. Next, DCL, data control language. The data control is basically the stored procedures, right?
Yeah.
Stored procedures, views, and they are all called data control language. We can, if you want, we can see the example. Okay. Okay. So DCL data control language, it is used to create roles. Okay. This is for roles, permissions, and referential integrity, as well. It is used to control access to database by security. Okay. Sorry. So DCL is different. TCL is the TCL is a transactional control language. It is used for transactions occurring within a database. So this is basically commit. When you insert the data, when you insert the data into a table, after that you have to commit, right?
Yes.
So commit and roll back, these are all transaction control. So after you execute a transaction, when you have to complete whatever the commands you use to control those language, the language used to control the SQL, that is basically transactional control language. The DCL is grant, revoke, basically user permissions. Okay, whenever you want to give a permission to user, whenever you want to grant a role, whenever you want to grant like insert, update roles, okay, and then security, user access, these are all called data control languages. Okay. So DDL is basically like create, alter, drop. These are all data definition languages. Whenever you are touching the database structure, it's a DDL. Whenever you are manipulating or modifying the data, then it's a DML. Okay. Any questions?
No, sir.
Okay. Okay. So create database. Okay. Simple. Whenever you create a database, you just use the create database and then database name. Okay. But it's very rare that you create a database because you are a developer. You are not an admin. You are not a DBA. So only the DBAs will create the databases. Okay. Most of the time, 99% of the time, you never ever create a database. Okay. But it's good to know that what is the command for creating a database. You can create a database if you have any database in your on your computer. So you can use the command. It's just simple: create database and then the database name, anything you want. Okay. So drop. You can drop the database like you drop the table. So drop database and then the database name. Simple. Okay. Create table. So creating a table, it should be simple if you know what to do. Okay. So you creating a table, create table and then table name. Then you will give column names and also the data types. Okay. Okay, here like this. So create table, person ID and then data type. Name, data type, address data, city data type. So like that. So we can actually use it. Okay. The menu has the right deal is available and will look at any changes. Feel free to experiment. You can restore the database at any time. Okay. So you are not mentioning here. You are not mentioning any not null or null statements. Okay. So let's say the person ID. If you want this to be not null column, then you just give not null. But all the other columns are nullable. Okay. Since you are not mentioning not null for the other columns, though by default it will take it as a nullable column. Okay. So if you want any columns to be not null, you have to specify it's a not null. Then only it will assume that okay, we don't have to take any nulls. Okay. So that's it. Okay. So create a table using another table. Create table name as, so like we did yesterday, inserting the data from one table to another table, right?
Yes.
So same thing, creating a table, but you are selecting the data from other tables. So let's see. Create table name as, this is one part. Okay. So you are selecting column 1, column 2 from existing table name. If you want Bearer clause, you can use it. Otherwise, no, you don't need. Okay. So that's it. That is the query. Select column 1, column 2 from table. Okay. Drop table name. That's it. Truncate table. Do you guys know what is the truncate means?
For deleting the data, same as delete statement.
Exactly. So you can use the delete statement to remove the data from the table. You can use truncate statement also to delete the data from the table. Okay. So you can use either of the statements. Only difference is if you run a truncate statement, you cannot roll back. There is no rollback once you run the truncate. But if you run the delete statement, you can roll back. That means the data will be put it back. Okay. into the table. But if you run the truncate statement, there is no rollback. That's it, your data is gone. But one advantage of the truncate statement is it will run so fast compared to delete statement. Okay, so let's say if you have like 100 million rows in a table, you want to remove the data from that table. If you run a delete statement, it will take 1-2 hours. Okay, but if you run a truncate statement, just like that, it will truncate the data. Okay, because it's not keeping anything in the memory, because there is no rollback. It will just flush the data. But if you run delete statement, what it has to do is until you commit, it has to put in the memory. Until you commit, the data has to go somewhere. Put it in the memory. Okay. So once you commit, whatever the data was in the memory, it will delete. But until you commit, that data will be in the memory. So because you never know, you have to run a rollback or not. So that is why the delete is so slow compared to truncate statement. Okay, this is the interview question. What is the difference between delete and truncate? So you have to keep it in mind. Truncate will run faster. Delete will run slow because it has to keep the data in the memory. And then also there is no rollback for truncate, and there is a rollback for delete. That's it. You just have to explain the differences between the truncate and delete.
Yes.
Okay, alter table. So alter table is basically whenever you want to modify the columns in the table, whenever you want to modify or to remove the column names in the table, you use alter statement. So it is also simple. Alter table name. Then you can add a column name and the data type, and then you can also drop the column name, drop column name, and then inside the alter there are so many things. Let's see here. Alter table, then add column, alter table, drop column, alter table, alter column. Basically, you can rename the column name, or you can change the data type of the column using like this command: alter table, alter column data type. You can modify. See, so there is some differences after the alter table command. See here, for SQL Server, this is alter column. For Oracle, 10G and later it's modify. See, so every database they use the major commands, but some inside after the major commands, there are minute differences are there. Like see here, they are using modify, but for SQL Server they are using alter column. Okay, so these kind of differences will be there, but you have to know those differences. For ETL, you never know what kind of database you are using. Okay, most of the times you will have at least 2 databases if you are going to any company. So okay, SQL alter table example, alter table person. What is doing here? Now we want to add a column name date of birth in the person table. Okay, add date of birth, date. Here date of birth is added. Change the data type example, alter table, alter column, date of birth, year. So this was before date column. He added like a date of birth column as a date, but now he is modifying to year. So you only store year in the table. Okay. And the next example is drop column. You want to drop delete the date of birth column. So he just added, but you want to delete it. So let's say drop column, date of birth, that column was deleted from the table. Okay. Any questions?
No, sir.
Okay. SQL create constraints. So constraints, what are the constraints mean? Any idea?
The rules or conditions we can use on the columns generally.
Okay. Razima, do you know constraints?
I mean, the rules or conditions we can specify on
Okay.
column name, column type.
Okay. Paramesh, do you know?
No, I don't know.
Okay. So constraints. Constraints are basically you can mention primary key, okay, foreign key, not null, check constraint. So these are all constraints. You can, even the primary key and foreign key is also a constraint. Okay?
Okay.
Yeah. So let's see. SQL constraint. So here, not null, unique, primary key, foreign key, check constraint, default, and index. So not null. Not null is just nothing but it will make sure that there won't be any nulls inserted into a table, right? So here I think I wrote it right before here. The not null, when you are creating, you are giving a not null, right?
Yes.
So that was the constraint. So it's a not null constraint. So it ensures that column cannot have a null value. Unique constraint, it will ensure that all values in a column are different. So basically you cannot insert, if you have a key 1001 already for one column, if you insert same 1001 in the same column, the insert will fail. It will tell you that unique constraint is violated. Okay, the error will be unique constraint is violated. That will give you, because you are trying to insert the same key into the table. Okay. Next, primary key. You already know the primary key. Basically, primary key is nothing but a unique constraint and also a not null. You cannot insert any nulls into primary key. You cannot also insert into a unique. Basically duplicates. You cannot insert a duplicates into the primary key. Okay. So basically, it will have both it is a combination of both. Foreign key. Foreign key, you guys already know. It is a key column in the other table, and then it will be connected to a different table. Okay, it is uniquely identifies a row or record in another table. Okay, it's a connection between two tables, but it is for a primary key in one table. The same primary key will be foreign key in the other table. Okay. Next one, check constraint. Check constraint is it will check whenever you enter whenever you insert the data, it will check. Ensures that all values in column satisfies a specific condition. Okay, you can add anything in the check. Okay, so let's say if you have a check constraint and then you want to check if the value is between let's say between 1001 and 9999. Okay, if you have that check constraint enabled on the table, whenever you insert the data, it will check if that value is between that values. So if you say, let's say if you enter 9999, then it will fail. Sorry, 999, it will fail because it is less than 1001. So these kind of constraints are you can use those conditions in the check constraint. Default, it sets the default value. Okay, so default is nothing but whenever you create a column, whenever you have a table and then you want to make sure that one column will always have same value. Okay, I will show you all the examples, but I'm just explaining the theory. So we don't need to go through not null, unique, primary key, and foreign key, right?
Yes, sir.
Do you want me to explain? Because let's see, they have the theory with examples here. Do you want me to go through, Paramesh?
Can you show me the foreign key?
Foreign key? Okay, sure. We can go through default, index, and check also because it will be easy if I go through the example. So let's start with foreign key. Okay. So foreign key is a key used to link two tables together. Okay. So foreign key is a field or collection of fields in one table that refers to the primary key in another table. Okay. Let's look at the example. We have persons table. Okay. Person ID, last name, first name, and age. We have order table. Order ID, order number, and person ID. Right, Paramesh?
Okay.
So what is the foreign key in the order table?
Foreign key. Primary key or foreign key?
Foreign key. Which column is foreign key?
Okay, we are getting from the person ID.
Yes, exactly. What is the primary key in order table? I mean, by looking at it, what do you think? Which one is the primary key?
Order ID, I think. Order
Order
number.
ID, right?
Anything
So,
can.
yeah, no, order ID. Most of the time, the order IDs are because you can have multiple order numbers inserted into the table. Okay,
Okay.
you can be multiple orders. Sometimes you can have duplicate order numbers also. Okay, so yeah, right. So order ID is a primary key for order table, but person ID is a foreign key. Okay, but the person ID is a foreign key in the order table, but it is a primary key in the person's table, right? Right. So this here is the thing. So in the person's table, person ID is primary key, but in the order table, it is also a key, but it's a foreign key. When you want to join these two tables, you can use person ID and then person ID. Okay. Okay, Parmesh, understand?
Okay.
Yeah. So simple. It's so the any key, it could be a primary key to the table, but a same key column will be there in another table. It is simply there to join them. That's it. It is wantedly created. Okay. Whenever they are doing data modeling, it is wantedly created so that they can join the tables in the future. Here it says the person ID column in the order table is a foreign key in the order table. The foreign key constraint is used to prevent actions that would destroy the links between the tables. Okay, another use of the foreign key, not only to join, but it is a child table also. This will be a parent table. This will be a child table. Okay, so if you insert a row into the person's table, it won't say anything because it's a parent table. Okay, but if you, without inserting the row into the person's table, if you insert into order table, it will fail because whatever the foreign key you have here, it has to be first available in the person's table. Okay, so let me give you a simple example. If you try to insert person ID 4 into the order table, what will happen?
It will give,
It will fail. It will fail because there is no 4, there is no number 4 in the person's table. Okay, so this will act as a parent table, this will act as a child table. Okay, so if whatever the foreign key you are trying to enter here, first of all it should be available in the as a primary key in the main table. So that is because it will make sure that referential integrity is maintaining. Okay, referential integrity, that is called referential integrity. A link between two tables, it's called referential integrity. So it's a parent table and child table. So a foreign key constraint also prevents invalid data from being inserted into the foreign key column because it has to be one of the values contained in the table it points to. Same thing. So whatever the value you enter, it has to be first available in the person's table. Do you want to try entering? You want to try example? We can go. Actually, let's see. So this is the person's table, right? Okay. Select star from persons. Run. What happened? PRSONS.
The P must be capital, I guess.
No.
there is no such table. There is a database right side of the page. Here is the database table names. Here, right side. There are only few.
Oh, okay. There is no person's table, I think. Yeah. Okay. Others is there, yeah.
orders and order details. I think those are linked. Right?
Oh wow, but there is so much data. It's not only one row. Shipper ID, order ID, customer ID, order date. It might be a different database. They might have multiple databases. Okay, where were we? Foreign key. Okay. SQL foreign key on create table. Okay, let's see this example also. Okay, create table. Okay, this is what I did. Then we can add like this: not null column, person ID, integer. Okay, this is how you mention the primary key. Okay. If it is Oracle, so this is MySQL database. Okay, but for Oracle and SQL Server, you can mention like this: not null, primary key, integer, not null. Okay, so basically you can mention both not null and also primary key. Actually, if you mention primary key, you don't even need not null. Okay, because it will have both. And order ID is not null, person ID. It's a foreign key. References means where that person ID is. You have to give you have to point out to the main parent table. Okay, so it is in the persons table. Okay, so you can just mention foreign key, but you also have to tell where that foreign key is. Okay.
Don't we have the identity?
Identity is in the SQL Server database, but identity is basically a sequence. Sequence means, as I said, it's only for system generated values. Identity is system generated. If you want to generate a random number, you can use identity.
You can increment the numbers, right? Serial.
Yeah, exactly. When you want to add random numbers and increment the numbers automatically, then that is the identity. Okay. It is a different function actually. If for Oracle it is called sequence, but in SQL Server it's called identity.
Okay. Where do we use it? It's a constraint or something else?
No, it's not constraint, but it is a data type.
Okay.
So like this. So here you given not null, right? You instead of not null and all these things, you can give identity, so that it will automatically take that as a system generated key. When you're creating a table, you can mention identity.
Okay.
Yeah. Okay. See, like this. Create table, ID number, integer, then identity.
Starts with 1, increment is 1.
Exactly. So that is in the SQL Server, you mention like that. Okay. Okay, this is done. Foreign key on alter table. Alter table, add foreign key. So basically, after you created the table, but then you decided that you want to join the table, or then you decided to create a foreign key, then you can do like this: alter table, and then add foreign key. That foreign key column name. Then you have to point out where that primary key resides in, where the primary key is. Okay. Basically just saying that add foreign key, and then you are mentioning the column name here. Okay, drop a foreign key constraint. Alter table, drop foreign key, you just keep the foreign key name. Okay, same thing in for Oracle and all those things are the same, only MySQL is different. Alter table, drop constraint and the constraint name. Okay, Okay, any questions on this one? I am foreign key. Ramesh?
No, sir.
No,
Very good.
yeah, good.
Okay. So you already have the SQL Server in your laptop, right?
Yes.
Okay. So can you guys practice these things? At least creating a table, altering the table with the primary key, foreign key, and all those things. Can you
Yeah.
practice them today?
Yes, sir. Sure.
Yeah.
Yeah.
We will.
Yeah. Please practice these things: foreign key, primary key, all the constraints. Basically, all the constraints, not null, check constraint, default, all those things. Just practice creating the table, altering the table. So you should be. I mean, you don't forget if you just practice one a couple of times. You don't forget in the future. Okay, just practice those things. So foreign key is done. Next, we'll go to check constraint. Okay, SQL check constraint. Check constraint is to limit the value range. So yeah, I told you, right? Range. Basically, if you want to define a range, like let's say if you want to restrict the column value from 1000 to 9999, so you can restrict like that. So every time you insert a value into that column, it will make sure that the value is between those values, between the range. It should be in the range. Okay, it will always check if the value is in the range or not. SQL check. Okay, create table. So this is how you give. You have the age column with the data type, and then you can add a check constraint. So he added a comma here. That means you are adding, this is like an extra column, but it's not a column. It is just a constraint. Okay, it is a check constraint, age greater than or equals to 18. So what is it saying is it will only take the values where the age is greater than 18. If you enter 17, what happens? It will fail. Your SQL will fail. Okay, your insert query will fail, basically. Understand?
Yes, sir.
Okay. Same thing. This is because it's MySQL. This is different, but usually for Oracle and SQL Server, because it is a constraint, we use like any other constraint, like not null constraint, like we are adding on the side, right? If you see here, they are specifying separately. Okay, same thing for we saw for primary key and foreign key also. If you see the MySQL create table statement, the basically except the not null constraint, all the other constraints they are adding as an extra column. Okay, but if you see the same thing, primary key and foreign key constraints for SQL Server database and Oracle database, they are adding on the side. Person ID, integer, foreign key. Order ID, integer, primary key. All the constraints are on the side, but here they are using as a separate column. Okay. Okay. So let's see here. Age, integer, check constraint on the side of that column. That means this will belong to this age column. The constraint will belong to age column. Age greater than or equal to 18. Okay. What are the other things? Okay, here constraint. So two constraints in one in one field. They are adding two constraints. Okay. So you have to mention if you can actually add like this also. You can add check age greater than or equal to 18. You can add that here, and check city is equal to sandness. You can add that here, but instead he added differently. Constraint, he mentioned that it is a constraint name. This is nothing, it is just a constraint name, don't confuse. Okay, then check constraint, age and city, both in the one area. Okay, he basically confusing, but I think he wanted to give a name to the constraint. So when you add a constraint here, right, check constraint, there is no name for that constraint, right? Do you see any name?
No.
No, there is no name for the constraint. But Here he is mentioning, he wanted to mention the name to the constraint, that's why, so this is the name. That's why he is adding all both the check constraint in one place, because he wanted to name it. Okay, constraint, check the name of the constraint, and then the constraint range. Okay, check constraint, age is greater than or equal to 18, also city name, anything. So that is what he did. Okay, alter table persons add check. This is basically altering. So you have the table already there. You want to add a constraint after the table is created. You can do this using the alter table command. Same thing, you can add constraint using the alter table command. Okay, drop constraint you can use in the alter table constraint. You can use drop. Same thing. Okay, you can drop the constraint anytime using the alter statement. Okay, any questions?
No, sir.
Okay. Default, simple. Default is a very easy constraint. Okay, here see, default sandness. That means whatever you enter into the city, it doesn't matter, the value will be sandness. So if you enter, let's say Illinois into the in the insert query, but because you already have a default constraint, what will happen is it will override the value you are entering. Understand? If you enter Farmington Hills in when you are inserting a data, because you already have the default constraint, so it will override the Farmington Hills and enter sandness value in the city. Okay, so that is the default. Basically, here you can see another example.
When we leave it as empty, or
even if you leave it empty also, it will enter the city name. If you enter a value also, it will enter the default value. So it doesn't matter if you leave it empty or if you don't, if you give the value, doesn't matter. It will default it to that whatever the name you gave. Okay.
okay.
So same thing. Here is basically defaulting the order date to get date. You guys know it's in the SQL Server. Get date is nothing but a system date, right? System date. So it will get the today's date and time, right?
Yes.
Yeah, today's date, sorry, not time, just the date. Okay, so he is defaulting order date to today's date. So whenever you enter the data, it will automatically insert the current date and date. Okay, that is the default function. Same thing, instead of, if the table is already created, you can use the alter statement to set the default value for any column. Okay, so basically alter column, set default is equal to this. And Oracle also same thing, modify, but you have to use modify city default that value. Okay, same thing, you can drop the constraints with the alter statement. Any questions on the default?
No, sir.
Okay. Create index. Okay, index. So index is basically okay. Indexes are used to retrieve data from database very fast. Okay. How do I explain this? Index. Index is different. Sometimes people confuse with index and primary key. So indexes are different. Primary key is different. Okay. The user cannot see the indexes. They are just used to speed up the searches and queries. Okay. How do I explain the index? Okay. So you have a, for example, let's take you have a map. Okay. Just like a world map or something. Okay, you take a push pin and put that push pin on somewhere in the map. Okay, so maybe let's take like 3 or 4 push pins and you put them on the map because you wanted to see those locations very easily. Okay, so if you wanted to go back and find out where the pin is it not easy or not?
Easy.
Easy, right? Yeah, you can just go and look. You're seeing the push pins over there on the map, so it will be easy. You can just go to that location directly in the map. So that is the index simply. So that is the index in the database. Basically, you are putting push pins on some columns, okay, so that you can find the data easily. You can also the when you run the query, the query will run faster because that column is already indexed. Okay, understand?
Yes, sir.
Okay, that's it. Simply mm, you are making some, you are taking some columns and then making them as indexes, so that you, whenever you run the query will run faster because you are already indexed that column, so all that columns will be put it in the memory, I think. Okay, so all the indexes will be in the memory, so that they are basically pointed out already. They don't need to go row by row every time you run the query. They are already in the memory. So that's why whenever you run a query on the indexed column, it will run faster. Okay, so when you create the indexes, let's say you have 1 billion rows in one table. Okay, if you want the data to run, if you want to extract the data faster, you can take any unique column, maybe you can create indexes on the primary key also. So you can create index on the primary key, or any unique field. Okay, so then whenever you run the query, it will run faster. I mean, comparatively faster. Okay, normal query, if you compare the normal query and the indexed query, so you can see the difference. The indexed column or indexed table, they will run faster. Okay, so the syntax is create index. So this is basically after you create the table, you have to use the create index command. Okay, create index and the index name on table. So you can use multiple columns for index. You can use just one column also for the indexing. Okay, so if you have 2 or 3 unique columns in the table, you can add them in the one index. Okay, yeah, otherwise you can add just one column also. It's up to you. So create index name on table, create unique index. Create a unique index on a table. Duplicate values are not allowed. Same thing. Like however you have the unique constraint for the indexes also, you can have unique index. Unique index is nothing but it's similar to unique constraint, so that you cannot insert in any duplicate values in the index. So you can, if you take multiple columns in the unique index, what will happen? You cannot have any duplicates in those columns. So basically, you have these columns should be unique. There shouldn't be any duplicate values for the create unique index. Okay. So see here, create index name on person's table. You are taking last name as the index column. Okay, but here let's see, he is taking 2 columns, last name and first name as the index. Okay, so you can drop the index after you create it using a drop index command. And so yeah, that's it.
What happens
Any
if you run this command? What happens?
It will create index. I think you can see. Today I'm using my personal laptop. Otherwise, I can show you the indexes in Oracle. Yeah, I'll do one thing. Tomorrow, I will definitely show you the indexes in my Oracle table. Okay. Sorry, not tomorrow. Monday. Okay. Monday, I will show you the indexes in my company database. Okay. So just remember me on Monday. I'll remember me to show you indexes. I will show you. Okay.
Yes.
Okay. So 410. Okay, we covered until index. Um, so Monday we will cover the remaining increment, views, injections, and hosting. I don't even know what is hosting, but we can go through functions. Okay, the functions are important. Um, Null functions, operator, data types, SQL dates, Oracle functions. Let's see what are the okay. Yeah, we can go through. We can go through some important functions, not all the functions, but we can go through some functions in database. Okay. Yeah. So these are, I think, these are very important. Add month, current date, all those things are important functions. So Monday I will explain all these things. So let's cover most of these sections on Monday, and then if there is anything remaining, Tuesday we can go through some more on Tuesday also. But Wednesday we'll start Unix. Okay.
Yes, sir.
Okay. So any questions so far on these things? Any questions? But please, guys, you already have the SQL Server database. Can you guys practice these things? Primary key, all the constraints. Just practice the constraints. These things should be easy, but just the constraints. Practice the constraints. Okay.
Yes, sir.
Monday I'll text you mostly 3 p.m. only. But if there is any changes, I'll text. Okay.
So about the
Okay. So
Unix,
remember, yeah.
about the Unix, I mean, you said you'll send a document how to install the EVM. I mean,
Yeah, if not document, I will log into your computer. Otherwise, I will send you the link.
okay.
How to download all. But I have to do some research because see, I'll show you. Can you see my screen?
Yes, sir.
Yes.
Yeah.
Okay, so this is the virtual machine. So it is basically a computer. Okay. I see how many things I have. I have a Teradata database.
Yeah.
This is basically virtual machine, but see Windows 7. I have my laptop is MacBook, but I have a Windows 7, and then I have a SAS. I have Hadoop. This is a big data I was talking about. Okay,
Yes.
so this is a Ubuntu operating system. Okay,
Yeah.
and this is Windows 7. So I have multiple operating systems in my virtual machine. So mostly I will try to get the same virtual machine for you guys for Windows. It's called VMware Fusion. But only problem is you have to find a key for that, like a license key. That is the only problem. We can just download for free, but we need a license key. If that's it, if we have that key, we can install Ubuntu. It should be simple. So let me show you how that looks like. Basically, I'm opening another computer. That's it. This is a Ubuntu operating system. Is it open?
Yeah.
Okay, so let me close this.
I think it's new version. I think new version or old version.
What is it?
It's Ubuntu. It's Ubuntu, right?
Yeah, Ubuntu. Yeah, Ubuntu. I think this is 6 months old. So here, see, this is the terminal. You can actually practice Unix commands. See, all you can execute all the Unix commands. See, that's it. So this is what we want, basically. So I will see if I can find a key for the VMware Fusion. Otherwise, there is one thing from Oracle company. I forgot the name, but yeah, I will
We
check.
can directly install Ubuntu, right, in the system.
You can install, but you will lose your current OS, right? So you will lose your current
No,
operating system.
no, we don't. We'll have to at a time. At the booting time, it shows the two operating systems. We have to select it.
Okay, but yeah, you can also do that. I mean, because this is very simple, because if you uninstall it, everything will be gone. But yeah, if you can do that, that will be good. Yeah, you can do that also.
Okay, what is the
Even if,
Oracle one? We'll try that first. Oracle.
yeah, because I prefer VMware because I don't know install two operating systems in my. But yeah, I mean, I have my old computer. I have two operating systems: Windows XP, actually three: Windows XP, and then Ubuntu and Windows Vista. So I have three operating systems on that computer. Yeah, you can basically divide your disk into two partitions and then install the Ubuntu. Yeah, you can do that also. Oracle Oracle VirtualBox, VM VirtualBox. I think this should be free. You can install it, I think. But only thing is I couldn't find the Mac version, so that is why I installed. Yeah, you can install this actually.
Okay.
Oh yeah, there is OS X also. You can install for Windows VirtualBox package, Windows host. Yeah, see, you can install. So can you guys install this
Yes, sir.
and then install the Ubuntu?
Yeah.
Okay.
So first install the Oracle VirtualBox, okay,
Yes, sir.
and then download Ubuntu. So I'll show you what it is. Ubuntu download. So they will ask you money, but you can simply make 00, okay,
Yes.
00, and then use Ubuntu for free.
You can continue.
Yeah, you can continue to the download. You can download now. So it will basically, you have to download this version, ISO. The extension should be ISO. Then you can install the Ubuntu on the virtual machine. Okay.
Yes, sir.
Okay. So do you guys want me to send you the links, or is that okay?
We are okay. I can say.
Okay. It should be simple. It should be pretty simple. So just download this Oracle VirtualBox. Then download the Ubuntu ISO. Then after you open the VirtualBox, so I'll show you how does it look like. Disconnect. No. Ah. 620. So that you have to browse and then show the ISO. That's it, done.